Hello, here you can see that the ladder logic diagram of start delta starter is there in the left hand side, and in the right hand side the start delta starter power circuit diagram has drawn. So we can see that here the L1, L2 and L3 are the three-phase supply, and PE, that is earthing connection, is there. Here you can see in this power circuit diagram that the main contacts of the main contactor is there, and the star contactor, that is the contactor which power contacts will drive this induction motor in star connection, that is there here. Okay, and the delta connection will be made by this power contact. So here at the left hand side in the ladder logic diagram, the start push button is there. It is momentary type, so when you will press this push button, then only it will be able to flow the power through it. When it will be released, then this push button will not be able to flow the current. That means this start push button is normally open type, NO type. Okay, so when we will press this start push button, then it will be like this. It will be NC type. Okay, in that condition. So I will put over here. That means this will be closed. Then the power will come through this start push button to here. Okay, but the current will not be able to flow through this path, though it is the parallel path, but it will not be able to flow because it is normally open type. Then the power will come through this stop push button because it is normally closed type. So the power will come through this stop push button, and then to the overload relay. It will energize the coil of the main contactor. Okay, so current will flow from here to here, that means through this contactor, and if we say it as neutral and this as the phase, anyone, it is L1 or L2 or L3, then the power will be, this will be the closed circuit and the main contactor will energize. If the main contactor will energize, in that case what will happen? This auxiliary contact of the main contactor will change its state. That is like this, normally open to normally closed, that is NO to NC. As well as these auxiliary contacts will also change their states like this. Okay, now if the push button is released, in that case the power will be able to flow through this path to this will be the closed circuit in that case. And what will happen when it is released, push button is released, in that condition again it is NO type, but the power will be able to flow through this path. through this path. Okay, to main contactor remain energized, these auxiliary contact, which is in parallel with the start push button, is known as the latching contact of the in this circuit. Okay, now as this auxiliary contact is closed, so the current will flow through this path. Okay, that means current will flow like this. Okay, and in parallel with the horizontal path, the current will flow in this path also. Okay, so what is this one? This is the auxiliary contact of the timer. This is the auxiliary contact. This is the coil of the timer, and this is the auxiliary contact of the timer. As this is normally closed type, that is NC type, and this delta contactor, that is this is the auxiliary contact of this one. So as this is the NC type, so this auxiliary contact will flow the current to the start contactor, and this timer will also energized as this is in parallel with the start contactor, so this will also be energized. Now if the start contactor, the coil of the start contactor is energized, in that case in the power circuit, these contacts will change their states. That means this will be like this, like this. Okay, this will be like this. But what will happen in that condition? The delta contactor, the coil of the delta contactor will not be able to energize because there is an interlocking. That means this start contactor, okay, the coil of this start contactor, as this is energized, so the auxiliary contact of this one is this. So as this is by default normally closed type, that's NC type, so when this coil of the start contactor, this contactor is energized, in that case this will be de-energized. I am marking this as in opposite direction, so this contactor will be open type. Okay, so power will not be able to flow to the delta contactor. So this coil of this delta contactor will not be able to energize, though the main contactor is closed, because of this one is NO type now at present, and this star to delta timing, that is delta, sorry, this timer, auxiliary contact of this timer is this one. This one is not closed at present. After a certain time, as per the setting is done over here, what will happen? This will become closed, and if this one is closed, in that case what will happen? This one will become NO type. Okay, if this one is NO type, in that case what will happen? the power will not, that means the current will not be able to flow through this path. Okay, will not be able to flow this path. That means current will not be able to flow through this star coil of this star contactor. If the power is not flowing through this coil of the star contactor, in that case this star contactor will go to its original state like this. This will become closed type. Okay, so if this is become closed type, then the power will be flow through this path, that is the current will flow like this. In that case, what will happen in the power circuit? These part this one will become again will become in NO state, normally open state, and these power contacts will become normally normally closed state, that is in NC state. Now you can see that the U1, V1 and W1 is a sequence at this end, but here you can see that W2 against the U1, this is the sequence is W2, U2 and V2. Okay, the phase wires interchange. So if we connect this path, in that case what will happen? It is forming these induction motor terminals, that is the coil of the induction motor is in delta condition, is in delta connection. Okay, so now this induction motor is running in delta condition. Okay, now if the stop push button is pressed, in that case what will happen? If it is pressed, okay, I am marking this in opposite connection, that is it is normally open at present. Okay. Now it is NO. So if it is NO, in that case what will happen? The current will flow up to this point. Current will not be able to flow here. So if the current is not flowing through this, in that case what will happen? What will happen? Then the main contactor will be de-energized and this one will become again normally open type. So current will not be able to flow through this path. So the whole system will stop. So the motor will not run in that case. There is another condition. If we do not press the stop push button, okay, in that case if the motor is in under overload condition, then what will happen? This overload relay will trigger. If the overload relay is triggered either in star connection condition or star connected condition or in delta connected condition, in that case what will happen? The same thing will, the same situation will occur, like this will become normally open type. That means the current will not be able to flow through this path. So the main contactor will de-energized like this. Okay, so main contactor, if the main contactor is de-energized, again the same thing will occur. This path will not be able to flow the current and the motor will stop. Okay, now the question will arise that why we will use and when we will use the start delta starter to start the induction motor. You can see that here it is written that start delta starter is used for the starting of induction motor. Start delta starter of induction motor is most commonly starter used for the starting of squirrel cage induction motor rated above the 5 HP. Okay, more than 5 horsepower motor starts with the start delta starter. Below the 5 HP induction motor starts with direct online starter, that is DOL starter, and more than the 15 HP induction motor starts with the auto transformer. Okay, in case the start delta starter of the motor first started in start condition, when the motor takes up the speed of about 75 to 80% of the rated speed, then it changes to delta connection. In this method, the starting voltage is reduced to VL, that is line voltage, by √3 times. Okay, so at the beginning the motor is started with reduced voltage condition so that it can overcome the initial loading, that is when the motor is at stop condition. In that case, from there, if the motor starts rotating, in that condition it has to overcome its moment of inertia. It has to gain the moment of inertia, and then when it starts rotating, then the standstill condition, whatever the load is there, it reduce in some percentage. So in that condition, the current requirement is within the rated power ratings of the induction motor. Okay. So if we start the motor directly, which has the power rating more than 5 HP, in that case what happens, the starting current puts the above the rated current, that is like 3 to 5 times more. Okay. So to reduce this starting current, to keep this starting current within the rated current limit, rated current setting, so the induction motor starts with the star connection by reducing the starting voltage. Okay, that is the phase voltage kept within the limit in a reduced state. Here the as I told this, here the VL means the line voltage, so therefore the starting current is also reduced, and when the motor achieves its speed of about 75 to 80% of the rated speed, in that condition the motor the terminals of the motor are made as delta connection, so hence the motor also not be overheated and the motor runs. So okay, thank you.